we're going to use point slope form. What is happening here? Of the equation of a line. Use point slope form. So point slope form is something we talked about earlier in the year. It looks like this. All right, so point slope form. What does it look like? It looks like this. Y minus y1 equals m times x minus x1. You may have seen this in Algebra 2 at some point. I think we talked about this earlier this year. The idea with this form of the equation of a line is you know what the slope is and you know what the point is. So the slope is the m value. So this guy is our slope. And if we put y1 and x1 together, we get a point on the line. So if we know those two things going in, we can write the equation of the line. Now I'm going to recommend that while you work through this, maybe when you're done with each problem, you check your answer on Desmos. It makes things a little bit interesting if you can see if you actually have the correct information on there. So we're going to just jump right in and try one. I want to write the equation of the tangent line for the function f of x equals x squared minus x minus 2 at the point 1, negative 2. So what I want to do is write the equation of the line using the function that we're given at a specific point. So if you think about what that might look like, just to give you a really quick sketch of that graph, and you could do this on Desmos if you wanted. I'm just going to put it on here for us to work with. So if we have the parabola that this is going to end up being, and I'm not asking you to go through and figure out all of this information on your own, and you don't even have to sketch this graph on your paper when you do these. But I want to give us something to sort of look at as we're working. So our parabola has a point at 0, negative 2, the point 2, 1, the point negative 1, 0, and then we know the point 1, negative 2 is on there as well. Yeah, so like right here. So our parabola does this sort of, goes a little bit below and then comes back up sort of thing. All right, that's what our parabola looks like. Again, I don't need you to spend a lot of time doing this. I just want to use this as a reference as we go through the equation writing process. Okay, so first of all, in order to write the equation of this line, we need to know two things. So we need to know the slope, and we need to know a point on the line. Okay, those are the two things we need to know in order to write the equation of this line. Now, the good news in this case is that we're actually given the point on the line, right? That's this right here, this 1, negative 2. So we are given this, and that's just 1, negative 2. We have that from the start. We don't have to do anything to figure it out. We have to do a little bit of work to find the slope. So remember, the slope of a tangent line to a graph, that's called the derivative. That's called the limit of the difference quotient. It's all of those things that we did last week in a bunch of different ways. On Friday, we talked about the shortcut. You are allowed to use that shortcut from now on unless I specifically ask you to use the limit. So we can use the shortcut for that, the power rule here to find our derivative. But that's the key to this, is we're going to need to find the derivative. So find the derivative. So find f prime of x, and we talked about that notation on Friday. Again, this is all part of what we sort of discussed on Friday. Okay, so what does that look like? Well, the derivative of that function using our power rule, and I've still actually got some of that written up on the board in the classroom. But what we do is we take whatever the power is of that term, we multiply it by whatever the coefficient is in front. So 2 times, in this case, 1 is just 2 times x, and then we reduce the power by 1. So instead of being 2, it's going to be minus 1, which is just 1, or 2x. You can write the 1 or you don't have to, it's up to you. And then we repeat that process. So we find the derivative for this term. The power this time is 1. Multiply it by the coefficient, so 1 times negative 1 will be negative 1. And then when we reduce the power of x by 1, we get 0. So we just get minus 1. And again, if you're having any trouble with this and you weren't here Friday, it'll be helpful if you watch the video. But we could also find this using the limit. If we went through and did the limit using the difference quotient, we will eventually get to 2x minus 1 as our derivative. What we can do with that, though, is we want to know the slope. Remember, this tells us the slope for any point on that function. I want to know the slope at a very specific point. So we want to find the slope when x is equal to 1. Okay, so that's what we're looking for. When is the slope? What is the slope when x equals 1? Well, that just means let's plug in 1. So we get 2 times 1 minus 1, and that's just 1. That's our slope. Okay, so we've got our slope. We were given a point. If we connect that back to our y1, x1, that is what this point stands for. It's a point on that line. That's our x1 and our y1. So we can use all of that information to write the equation of our line. And remember, we're using this form, y minus y1 equals m times x minus x1. We just plug in the 3 pieces of information that we have, and that's m, x1, and y1. So m, I'll go in order. Y minus y1. y1 is right here. That's negative 2. So y minus negative 2 equals m, that's right here. That's just 1, times x minus x1. x1 is right here. Also 1 in this case. So we get an equation that looks like that. Clean it up a little bit. We get y plus 2 equals, you can write the 1 times x minus 1. You don't have to. You can just write x minus 1 if you want. If I were to graph this, all right, my point is at negative 1, 2, 1, negative 2, and I have a slope of 1. If I go back up and sketch that on my graph, I'm at this point, and I have a slope of 1. So I go up 1, right 1, puts me here. I could also go down 1, left 1, would put me right about there. And if I look at that line, it does in fact look like it's going to be tangent. Now you could do this on Desmos as well. And I did that with my other class. I would just type in the function, put the point on there, and then type in your tangent line. And when you do that, as you guys can see here in the classroom, you can see that tangent line looks like it's tangent to the parabola, okay? So you could do Desmos as sort of a self-check mechanism to see if what you did is correct and makes sense for that particular function. So what we did is we first figured out what our slope was. We had to use the derivative there. And then we had a point that we were given, put all of that into the equation of the line. Okay, we're going to do one more that's a little bit kind of basic, and then we'll do one that requires a little more, thought. So let's go to our second example here. All right. This time, let's see, we're going to write the tangent line again. So the instructions are the same. For f of x equals 4x cubed minus 5x plus 3, find the equation of the tangent line at x equals -1. All right, so I'm going to give you a function, but this time I don't give you a point. Okay, I'm just giving you the x value. We'll have to actually do a little bit of work to find the point. I'm not going to graph this one on our example because I think it's a little bit more difficult to graph and that we don't need to go through all of that. But we need to find two things. So we need 1, the slope, and 2, a point. So let's see if we can't find those two things. So starting with our slope. Again, what we know is that the slope of the tangent line is in fact the derivative. So I'm looking at the function and I need to find the derivative. So I'm going to start with find the derivative. And this again can be done using our power rule. So tell me what we got here. Using our power rule, what do you think the derivative is going to be? 12x close to the second power.
Oh, because it's -1, yeah.
Yep, yeah, and then what? -5, perfect. That's our derivative. Now that gives us the slope of any tangent line, right? But I'm needing one very specific. It needs to happen when x equals -1. So we're going to find what happens when x is equal to -1 at the slope. So f prime of -1, that's what we're looking for here. And we're just going to plug in -1. So we have 12 times -1 squared, that's just going to be 12, minus 5, that's 7. That's our slope. Okay, so we've got m. We know what our slope is. We're almost there. Now, as far as the point goes, I know the x value of the point. So here's what I'm looking at. I've got this much of the point. I know we're looking at a x value of -1, but I don't know what the y value is. How do I find the y value?
You just plug into the original equation.
Yes, let's plug it into the original equation. So let's plug it into f of x. So f of -1 will be 4 times -1 cubed minus 5 times -1 and then plus 3. So that's 4 times -1 is -4 plus 5 plus 3. So that is 4. So now I know what the the y value is for my point. I was given the x value, use the original function to find the y value. Now I've got what x1 and y1 are. I've got everything I need to write the equation of this line. So that's the last part. Let's put those two things together and let's write the equation of the line. So putting those two things together, I'm going to use that y minus y1 equals m times x minus x1. I'm just writing it again just because it's sometimes good to write things a few times. It helps you to remember it. All right, so we have y minus y1. y1 is the y coordinate of the point, so that's 4, equals m, that's our slope. We found that was 7, times x minus x1, which is -1. And then I would just clean it up a little bit. I don't need you to go through and distribute the 7 and solve for y or anything like that. This is fine. If you can get it into the form of the equation here, where you've just kind of gotten rid of those like silly minus negatives or zeros and that kind of stuff, you're good. That's the equation of the line. That will be tangent to our function at the place where x is equal to -1. I would, again, take a minute, put it all on Desmos just to check your work. And I actually have this on Desmos. Again, for those of you in the classroom, you'll be able to see this. Original function, the point, and the tangent line. If we look at those three things, we can see that does look tangent. Okay, so it's just a nice little self-check. It's not necessary, but it can be nice. All right, last one. And this last one, I'm going to give you the information just a little bit differently. So again, for a given function, for f of x equals 5x squared minus 16x plus 12, find the equation of the tangent line. When f prime of x equals 4. So when I say f prime of x equals 4, what am I actually telling you? What part of that information that we need? So we need two things. Remember, we need
You're telling us the derivative.
the derivative, and I'm giving you a really specific value of the derivative, right? So I'm telling you what the derivative is at the point where it needs to happen. So I'm actually telling you the slope. I'm telling you the slope is 4. This is m. All right. So I still need to find the point where this function has the derivative, or has the tangent line drawn. So this is going to require a little more work. Let's just sort of explore what's happening with the slope for a minute. We know that slope is found when we do the derivative. So let's just for a minute think about what the derivative of this function will be. So looking up at our function, 5x squared minus 16x plus 12. What's the derivative of that going to be? So using your shortcut, what would you have?
10x to the first power minus 16.
Good, 10x to the first power minus 16. We know that that's what we get when we find the derivative. Now here's what else we know. We know when we put x into the derivative, we ended up getting 4. So I know that these two things are equivalent to each other. This and this. So what if I set those two things equal to each other? What if I said, okay, well, 4 has to be what we get when we plug in x. 4 has to be equal to the derivative. If I solve that equation, what am I actually solving for? And what does x represent? What part of this information am I trying to get at? Part of the point, yeah. So if I solve for x here, add 16 to both sides, and then divide by 10, what I'm getting is the x coordinate of the point. So what I just found is this. That's awesome. I have the x coordinate of the point. Well, now it's a lot like what we did in the previous problem, where once I know the x coordinate, I can find the y coordinate by doing what again? Plugging it into what? The original. Good. We want the output for the original function, so I can't see that on my screen anymore. So that would be f of 2 equals 5 times 2 minus 16 times 2 plus 12. So let's see. 10 minus 32 plus 12, 0? No, 10. 22, it's 10, negative 10, right?
Isn't the first one 20 because it's, oh wait, no.
Oh, 2 squared, you're right, nope.
Okay.
I knew that was,
Wait, no, because the original equation was 5x squared.
yeah, so it should be 20, yeah.
Oh yeah, because I was thinking the derivative. Okay.
Yep. So we're plugging it into the original function, and I was just putting in, like, partially the derivative, partially the original function. Either way, it does come out to be 0, right? Okay, good, because that's what I got first period. So hopefully they're not sitting there with their notes wrong. All right, so we've got our slope, we've got our x1, we've got our y1, we have everything we need in order to write the equation of the line. So let's put it all together. All right, so I'm going to go y minus y1 equals m times x minus x1. Again, I just write it out real quickly here, just so I know what goes where. Okay, so that means y minus y1, which is 0, equals our slope, which was given to us, that's 4, times x minus x1, which is 2, And then I can clean that up just a tad because, we don't need to write y minus 0. Yeah.
Should you simplify the 4 times the x minus 2?
Yeah, so that's a great question. I don't need you to. If it bothers you to leave it written that way, then by all means simplify it. But this is probably,
It doesn't matter, you can just leave it like that.
yep, this is fine. My goal is that you just come up with an equation. It doesn't have to be like written in point slope form, or it doesn't have to be written in slope intercept form or anything like that. Just leave it. It's fine. Yep. Good question. Good. Anything else? Any other questions that might bother you about this process? So the thing about this process is we are putting together the idea of a derivative with writing the equation of a line, which is something that was in like an algebra 1 skill. So we're putting this idea of a derivative, which is a calculus skill, connecting it with the idea of a algebra 1 skill, and that's a lot of what calculus is going to do. It's going to put together things that high level things, and then you're going to talk about putting it together with your algebra 1 topic. So all right, good. So you can begin to work on any of the assignments that are due this week.